everyone. So today we're here with Luis Felipe Lopez. He is an engineer from Colombia and he currently works at Base Bahay in the Philippines as the general manager. And so he's actually joined us for the 11-day course here in Bali. And it's really exciting because we've gotten the chance to do a lot of fun testing with him. And today we're really going to focus on one of the specific tests that we carried out, which is the bending test. And so we did that with a couple different samples. We did that with bamboo planks, which we'll talk about the different ones. We did it with a concrete plank and we did it with round pole bamboo as well. So that was pretty cool.
So hi Nara, and it's a pleasure to be here in the course again. I think this is the third time I attend the course as a speaker, as a trainer, and it's been such a nice experience. And today we have a super fun activity about bending, as were mentioned before, and then we are going to determine the bending resistance of horizontal elements in like beams and planks and all of that.
Yeah, great. So we tested out a couple different planks, right? And so the way that we did this was we actually got everybody involved and we set up the planks ready there and we got people to start loading on them, right? This is not something that you would typically do in the lab. Right?
No, definitely this is more like having fun doing tests, so involving the students as be part of the test. So we use the weight of the people to test these 4 planks. Just for you to understand what kind of planks we use, we use a reinforced concrete plank, 4 centimeters thickness, and we have 3 additional planks made of bamboo. One that we call it the open pinbu. It's like a dowel laminated bamboo with not glue, but with a lot of space between the slats. We have a traditional dowel laminated bamboo or pinbu that the very common use in Bali for floor systems, and we have a laminated bamboo with glue plank. And then the idea here was to put the people on top of these planks and see with the summatory of the sum of the weight of these people to check if they break, and also the deformation in the case they didn't.
Yeah, I think the results were really interesting. So first of all, let's talk about the different ones one by one. So we started off actually with one that you had not tested before, which was the open pinbu plank.
Yeah, this was a surprise, and I have to confess that I was a little bit skeptical with that plank, and actually it resists a lot. It resists around 640 kilos and people on top with only a self-weight of 15 kilos. That's very light. And at the end, we were not able to break the plank, only getting 3 centimeters deformation in the center was the maximum. But when the people stand out of the plate of the plank, the deformation disappears. So we were always in the elastic portion. So very interesting material to explore and to test.
And so that's something you've not tried before. Is that something that you're gonna try now?
Absolutely, we will see. That could be like a light version of the pinbu that we are testing in the lab right now.
Okay, and so since you mentioned pinbu, let's talk about pinbu. How was that, like especially compared to the open pinbu?
Pinbu, I found a very fascinating product. As I mentioned during the test, this was developed for a person in Colombia. His name is Antonio Giraldo, later improved by George Stan, and here in Bali is where explode and it's being used for bamboo U, bamboo ibuku, and bamboo inda in the most fascinating ways. But it was always a secondary element, never like a main structural component. And 8 years ago, when I came the first time to Bali and I saw, I thought, oh, this has a lot of potential. So with Professor David Trujillo from Coventry University, we had been working in the development of this pinbu as a structural element. The scientific name is now Dowel Laminated Bamboo, and we are testing. And then I have all my bets in that plank. We make a plank with 4 centimeters thickness. By the way, all the planks we were testing in almost 2 meters span. And we have a total weight of that plank of 20 kilos only.
And about 25 for that one.
Yeah. And then we put a total of 913 kilos, almost a ton in people on top of that plank. with only 3 centimeters deformation. So we matched the deformation of the open pinbu that was 3 centimeters with almost double the weight.
That's insane.
Yeah,
That's wow.
fascinating.
Yeah, super cool. And what do you think are possible kind of applications now of Pinboo, now that we're trying to test things out and see how it actually works, because it's something that maybe wasn't necessarily tested all that much? What do you think are possible future applications down the line?
Yeah, for now, the testing are very promising. We're still far away to have conclusive results, but I see in the Pinboo first working in as a plank for floor systems without joist, like self-supported planks that
Yeah.
can work as a floor system in 2-story houses or 3-story houses. And in the future, the ambition is to use Pinboo as a shear wall system. So we will work in that direction as well.
That's really interesting. Yeah. All right. So the one that we tested after the Pinboo was the concretes.
Yeah.
So this was an interesting one because I think sometimes people come, not necessarily to bamboo you, but people just kind of have this impression that, oh yeah, I mean, we've used concrete for quite a few decades now and we're used to how it works. And a lot of engineers, I'm sure, are pretty comfortable with concrete and maybe not necessarily bamboo, right? So how was that test?
Yeah, let's be clear. I mean, concrete's a nice product. I
Yeah.
don't want to say that concrete is a bad product, but right now in this world, we are using too much concrete, and we can change that. We can replace some of the components for other that are better in terms of environmental performance and things like that. And here we want to show that concrete is not as good as we normally think. And then we took this plank that was 4 centimeters thickness, reinforced with rebars, and we started to put people on top, and we reached only 590 kilograms of weight, but initially with 7 centimeters of deformation, but finally it breaks. So we break the plank in bamboo. It was very fun to see it break and breaking, and but definitely we don't reach too much load.
Yeah. And I think that really opened up the participants' eyes that, yeah, okay, like, yeah, we're all here because, I mean, usually participants come to the course because they're interested in bamboo and they see the potential of bamboo. So I think this really put that into perspective with regards to, okay, like, I mean, this is what we're used to. This is what we see in the cities around us. And now, okay, what if, you know, there are other options out there, right? Including bamboo.
Yeah. And actually another topic that is very relevant is the weight of the planks.
Yeah.
So we say that the open bamboo was 15 kilos, the pinbu was 25, and we have another plank that laminated that was almost 30 kilos, 27, 30 kilos, but the concrete plank was almost 80 kilos. So it's 4 times the weight, and the amount of carbon emissions compared with the bamboos are 10 times.
Yeah, that's true. Yeah, I think, yeah, definitely, like, with regards to that, it would be very different, right, as well. So then we also had the laminated bamboo. How was that?
Laminated bamboo, as expected, performs very well. The plank reaches the highest weight. We were able to put more than a ton, 1,050 kilos in total of people. Actually, we couldn't have more weight because there was no space to put more people. It was very super funny, and we have a lot of fun on top of that plank, trying to don't fall, all of us. And at the same time, we were hanging there and trying to don't fall. We were measuring the deformation. So with 1 ton and 50 kilos, we have a deformation of 4 centimeters. But here, what is interesting is let me took the laminated bamboo and the pinbu.
Okay.
Because if you see both of them, the difference in weight was less than 100 kilos, 120 kilos only.
Yeah.
Difference between the two of them. However, the pinbu has a lower deformation, and the laminated bamboo a little bit more. So I will say that they perform similarly, like same thing. Not too much difference. However, the cost price is enormous. It's tremendous, and also the pinbu don't use glue.
Yeah.
So the carbon footprint of the pinbu is super small. compared with the laminated bamboo and the industrial, the energy that you need, the waste that you produce in the bamboo. So makes pinboo a more interesting alternative in the future.
Yeah. Yeah, I think definitely. I mean, so far here in Bali, for example, we do use pinboo for things like furniture, and also, again, for flooring, right? For planks for flooring. So I think now this can, like you mentioned, open up so many more options for how we actually use pinboo structurally, because sometimes we tend to use it more as not necessarily a very load-bearing element, which now we can see from just these kind of at-home tests that we've done, all these possibilities open up for us. So I
Yeah,
think that's really interesting.
absolutely. Yeah. And we have an additional test in ARA that was our round pole test. That's we're trying to simulate the ISO standard that we normally make in a laboratory, of course, in a more countryside yes, but also having a lot of fun and using blocks of concrete to simulate the load.
Yeah, so why don't you talk about how we set up that test?
Yeah, in the ISO standard, normally you use an span that is 30 times the average diameter of the bamboo. In this case, we use a bamboo that was around 10 centimeters,
Yes.
and then our span was 3 meters. Then here in Kukul Farm, in the Bamboo U campus, we use a platform hanging at the third part of the bamboo, and that we start to apply these concrete blocks. Each concrete block was around
I think about 11 kilos.
11 kilos. Yes, is what they mentioned. And then we were adding and measuring the deformation, looking and adding more, and then people start to be impressed about the amount. And we complete
67, I think.
67 blocks plus the platform, and that means we need 780 kilos to break the bamboo. And it was super interesting to see the failure mode. We get a crack along the neutral axis, like a shear failure, but induced by a pre-existing crack. So it show also to the students that is why we use safety factors. We need to reduce because bamboo naturally has the tendency to have cracks. That's something that you basically cannot avoid. And then if you use values with very unsafe values of safety, so it will be dangerous. So we finally get 780 kilograms of load, and that convert in a strength of 630 kilograms per square centimeter.
That's impressive.
Yeah.
Yeah, that's amazing. And so how does this test that we did kind of, do you think that it can differ from the results that you guys see in the lab, for example?
But not too much. Actually, with Luis, we were talking about the load that we were expecting for this test. And then I tell him normally in the lab, a bamboo like this size, we get something between 700 and in some cases go to 1 ton. But because the supports are not very well
supported.
Yeah, probably we will be around 700 and the load was 780. So I think it's not that different. I think the problem started when you want to measure modulus of elasticity, because you need to have a more precise measurement of the deformation. And that is super complicated in this kind of test.
Yeah, that's fair. And what about the species? How does the species impact things like the modulus of elasticity and the bending strength, things like that?
Yeah, what we get in the laboratory is, for example, some species in the global north, like moso bamboo, has lower modulus of elasticity than the tropical ones. Among the tropicals, I would say Dendrocalamus asper, Guadua, even Bambusa brumeana presents high modulus of elasticity. And other tropicals like the Bambusa vulgaris are quite lower. So it's important to know this value, because the deflections of your elements depends of that value. That value tells you how rigid or flexible your material is. Higher the modulus of elasticity, better the performance and beams.
Interesting. And so, based on that, we were just talking about the species. What do you think is the best species to use? And I know you've answered this before in other places, but let's put it in this video as well.
So it depends who you ask. The Colombian guy will answer immediately, what was the best species? But that's not the truth. The best species, as I always say, is the species that you have around you. So we have Dendrocalamus asper beside us. That is the bamboo we need to use for building. I mean, don't make sense to bring bamboos from the Philippines to Bali or from Bali to Colombia. We use what we have around. I mean, some maybe projects or applications require specific species, then you don't have choice. That's totally different. But if you really want to do a big scale project, you need to work with the species around you and then understand them and see how you can apply the solutions that you need.
And how would you recommend that people go about understanding these species that they have available, like in their area? So, for example, I mean, at Base, you work with testing certain types of species that are available in the Philippines. But what about parts of Africa or parts of Latin America that might not have these species? For these people that might not be in those areas or have similar species to you, how do you recommend that they go about testing or working with these?
Yeah, so in Base, actually, we focus first in 5 species. We choose 2 local species that are the most common in the Philippines. Those are Bambusa blumeana, that also exists it's a species from Southeast Asia, also exists here in Bali. And we have Bayok or Bambusa meridiana, that also is a kind of species that is very common in Southeast Asia, but very predominant in the Philippines. And the other 3 species we choose were on purpose chosen because they are, or we consider them, global species, meaning you can find those species in Latin America, in the Caribbean, and some of them in Africa, in Asia, and in the Pacific. And those species are wadwa. So wadwa, you find it in South America, Central America, in the Philippines, in Indonesia, and other countries. Have been introduced to many countries. The second is Dendrocalamus asper of giant bamboo. We have it in Ecuador, in Colombia. We have few clumps, not too much, but in Mexico it's very popular. And here in Bali and Philippines, everywhere.
And it's being introduced, I think, into other parts of East Africa and stuff as well now.
So you can consider a global. And the third global species is Bambusa vulgaris, really one of the most criticized species in the world because it's super starchy and it's very prone to insect attacks. But if you treat it well, if you work well with the material, you can still work. Now, talking about mechanical properties, Sciens vulgaris is the species with the lowest performance, but it's still okay. You can build with that if you know the properties. So what we are trying to do also in the Base Innovation Center in Manila is to find trends, patterns that allow us to predict the resistance of other species. And right now, if you want to do the full characterization of a bamboo species, you need to test 800 specimens, and that is a lot of time and a lot of math.
Yeah.
And then for countries with no resources and no laboratories, it became very complicated to do that. So what we're trying to do in Base is using the species in the Philippines and others in Nepal and Sri Lanka, we want to create these trends that people in, let's say, in Tanzania can take their local species, make few tests. I am talking maybe 10 or 20 only, and with that they can find the position of that species in the trend and infer the rest of the mechanical properties. That's what we are working right now. Soon we're going to publish a paper, a scientific paper that everyone can use for that purpose.
That's awesome. Yeah, I think that'll really help with bringing bamboo construction to other parts of the world where it might be only just starting out or, you know, people might not have all that much awareness. I think that'll be really helpful for that. So yeah, that's great.
Super.
Yeah, great. Well, thank you so much for being here today, Luis. We really enjoyed this talk with you. And thank you for joining us at Bamboo U for this 11-day course. I think all your experience and also the way that you just made learning so much fun really was beneficial for the participants and also for us as the team. We also learned a lot of new stuff today.
Thank you, Nara, for having me here in this course. I really enjoy my time in Bali, participating, learning from the students. Remember, this is a two-ways learning, so we learn a lot from the students. They have great ideas that always want to explore. And I want to invite any of you on the other side that you want to learn about bamboo construction in the best place in the world, come to Bamboo U. You will have a lot of fun and you will learn from the best.
Yeah, and we have a little surprise coming up in the next couple of months, and that's basically that we are launching a new bamboo engineering course in collaboration with Base Bahay,
Yeah,
which is
absolutely. That's
really,
super exciting.
really
Yeah.
exciting. We've been doing a lot of filming both in the Philippines and here in Bali to just put together those videos, and it should be coming out hopefully in a few months. So that's really exciting.
Yeah, we're super excited also in base of this new alliance between Bamboo U and Base Bahay, and we hope this is the beginning of a very, very strong collaboration in the future.
Great. So stay tuned. Make sure that you're subscribed, and we'll see you next time.
Bye bye.
Bye.